Hello, dear students. I am glad to meet you at our course. Today we are going to discuss beams, girders, and joists. Let's start. A beam is a structural horizontal element that can withstand vertical loads either applied laterally to their axis, as well as bending moments and shear force when weight is added to these beams. They typically transfer loads imposed along their length to their endpoints, where the loads are transferred to walls, columns, foundations, and so on. The words girder, beam, and joist are used interchangeably, but important differences distinguish them from one another. Girders are the main horizontal supports of a structure and support smaller beams. All girders are beams, but not all beams are girders. The fundamental differences between a girder and a beam are size. In general, workers in the construction industry refer to large beams as girders. There is no strict width, length, or weight cutoff. Builders look mainly at how the component is used. If it is the chief horizontal support in a structure, it is a girder. If it is one of the smaller structural supports, it is a beam. For example, the structural support of a bridge is typically a girder, while the smaller supports of a residential home are beams. Functionality. Both have the same goal, to resist forces by bending. Girders typically have the same I-shaped design as beams, but they are mostly used as box or Z-shaped members as girder bridges, which are the most common and simple bridge types used in construction. Beams that support the structural integrity of the buildings can be found on floors, walls, roofs, ceilings, and decks. Since girders mainly support smaller beams and construct bridges and flyovers. Load-bearing capabilities. Girders carry dynamic loads and rolling loads. A girder is a primary beam. Its main job is to transfer loads to the columns upon which it rests. A beam is a secondary beam. Its main job is to transfer its loads to girders, which then transfer the load to the columns. Fabrication. Girder can be made from a variety of construction materials, such as concrete, stainless steel, or a combination of both. For example, girder fabrication consists of load requirements from smaller beams the girder will support. Beam fabrication does not. Joists are like the skeleton of a building that supports the load which the floor is built to bear. Joists are technically beams that typically span relatively short distances compared to beams and are made of steel, wood, or engineered wood. Joists rely on a beam as their central support in both light and massive construction projects. This is because joists can either be placed on or beside beams to allow for the proper and efficient load transfer. A joist is a horizontal structural member used in framing to span an open space. Its function is primarily the same as beams, except joists are supported by wall framing, foundations, or beams. Joists usually run between wall or rafters to support a ceiling or a floor. In engineering, beams are classified into several types based on many factors. Based on the type of support, beams are mainly classified into following types: simply supported, fixed, continuous, cantilever, trussed. Beams can be classified based on geometry as straight beam, a beam with a straight profile; curved beam, a beam with a curved profile; taped beam, a beam with a taped cross-section. Based on the cross-section shape, beams are divided into I-beam, T-beam, C-beam, L-beam, rectangular beam. The rectangular beams are those which have cross-section rectangular in shape. These types of beams generally experience tension at the bottom and compression at the top. They are the most common types of beams used in building construction, from small house construction to high-rise building construction. I-beam is a structural member in the shape of an I, meaning a central web with a crossbar at the top and at the bottom. It is made of steel, concrete, or fiberglass. I-beam is generally used in the construction of manufacturing plants, multi-story buildings, etc. The beam which has a cross-sectional shape like T is called T-beam. This beam is generally cast monolithically with the slab. As a result, the slab acts as an integral part of the beam and bends in the longitudinal direction of the beam. The slab portion is called flange for T-beam. The beam portion below flange is called the web. T-beam allows us to select a larger span compared to the rectangular span because the deflection of the beam is greatly reduced. C-beam is a beam which has a channel section meaning C-section. The shape provides a superior structural support, making it an ideal product for frames and braces used for machinery, enclosure, vehicle, building and structural support applications. L-beam is provided at the corner or around perimeter of a slab. The end beams which have slabs only on one side are also called L-beams. Generally, these beams are cast monolithically with the slab. These types of beams generally found at the corners of buildings on which the roof slab is not projected out of the beam, corners around the staircase, lift openings, etc. There are different types of beams based on loads and supports. A simply supported beam is one of the important and simple types of the beam. It is supported on both the end. At one end it is pinned and the other is either pinned or rollers are used. Fixed beams are the types of the beam in which both ends are fixed and the rotational movement is restrained. In reality, all the high-rise buildings are made of the fixed beam, but the only way of fixing looks different. An overhanging beam is one like a simply supported beam, but its one end overhanged or extended from support to some distance. In the case of an overhanging beam, one end of a beam supported by a column and the other end is overhanged without support. An overhanging beam generally used to make shades or balconies can vary from 40 to 120 centimeters in common residential buildings. Thank you for your attention, dear students. Next time we are going to discuss trusses. See you next time. Goodbye.